Good morning, students. Welcome to another session of Distributed Generation and Smart Grid. Today we will be seeing various distributed energy resources and specifically combined heat and power plant, or abbreviated CHP. So let us quickly go through a quote by Mahatma Gandhi: "Education which does not mold character is absolutely worthless." So this is a very important quote. This module 2 basically deals with distributed energy resources and control of microgrids. Today we will see what are the different various distributed energy resources, and specifically we will see combined heat and power systems. So various distributed energy resources are listed here. The first one is the combined heat and power systems, or they are also called cogeneration systems. Then wind energy conversion systems, solar photovoltaic or PV systems, small scale hydroelectric generation, storage devices like fuel cells, battery, etc., electric vehicles, micro turbines, and other renewable energy sources. So let us come to combined heat and power system, or cogeneration CHP system. Combined heat and power system, also known as cogeneration, refers to the use of exhaust heat of any production unit for another process requirement. So here you can see you can see this graph, and you can see that this 45% of heat which comes out of 45 plus 15, that is 60%. 45% can be used for some other purpose, whereas 15% we cannot do anything. It goes as heat loss to the atmosphere. So this 45%, if we use it, then the total energy output becomes 45 plus 40, 85%. So by using a cogeneration system, so the energy output can be enhanced, typically from 40 to 88 to 90%. So this is another picture showing the efficiencies without cogeneration and with cogeneration. So without cogeneration, the efficiency is roughly 55%, whereas with cogeneration, the efficiency rises to 87%. Okay, so this is a comparison of energy efficiency with and without cogeneration in a conventional coal power plant and heating system. The heat produced at moderate temperatures can be used in absorption chillers for cooling. So this is how we are going to use moderate temperatures. This in turn results in improvement in the energy utilization of the unit. So the overall thermal efficiency increases from 40 to 50% to 70 to 90%. CHP does not have to be a renewable source of energy. It is not necessary that CHP should be a renewable source of energy. In many cases, the CHP installations make use of natural gas as a source. The use of biomass as a source is the only renewable form of CHP. So that is important. Micro-CHPs are very small CHPs, and they are typically used for space heating and producing electricity. So these are commonly used in cold countries for domestic heating, used in hotels, shopping malls, and offices. So a typical example is a unit that produces 1 kilowatt electricity together with 7.5 to 12 kilowatt of heat. So micro-CHP systems are installed in smaller premises like homes or buildings. Okay, micro-CHPs are small sized CHPs, and they are based on the following technologies. So internal combustion technology, Stirling engines, micro turbines, and fuel cells. So we will see the first two in this session, that is IC engines and Stirling engines. So let us come to internal combustion engine. So from the name itself, the combustion happens inside a combustion chamber with or without oxidizers. And commonly used fuels in IC engines are petrol, diesel, gasoline, natural gas, or LPG. Liquid and gaseous biofuels like ethanol and biodiesel also can be used for internal combustion. So we need to provide a spark ignition for a petrol type of IC engine, or we have to provide a compression ignition in other types of fluids. The next one is a Stirling engine. Stirling engine is an external combustion engine. The combustion takes place outside the chamber. Okay, though heat can also be supplied by non-combustible sources like solar, geothermal, chemical, and nuclear energy. So heating can be done by solar or other energy sources. So basically Stirling engine uses an external heat source and an external heat sink. So the working fluid is normally a combination of air and hydrogen or helium gas in a sealed chamber. And the different processes are the cooling, compression, heating, and expansion. The hot heat exchanger is kept in thermal contact with an external heat source, while the cold heat exchanger is kept in thermal contact with an external heat sink like a radiator. So refer back to the last picture. When the gas is heated, it expands, and in a sealed chamber, normally like a piston and cylinder, and acts on the power piston to produce a power stroke. So this linear motion can be converted into circular motion by using proper linkages. When the gas is cooled, the pressure will drop down, and then less work has to be done by the piston to compress the gas on the return stroke. Stirling engine as CHP. The primary heat source enters the engine heater and produces mechanical power. And the waste heat from the engine's heater can be used for heating application. So the advantages of Stirling engines are high energy conversion efficiency, and their operation is very quiet, highly reliable, low maintenance, pollution free. The disadvantages are the higher capital cost and the size. Typically they are used for water pumping and electrical generation. So this is a typical Stirling engine using a solar concentrator. You can see a dish type of antenna, and a lot of mirrors are sticked on the dish antenna to concentrate the solar energy to a single point, and at that point the Stirling engine is kept, and the Stirling engine output can be used to generate electrical energy. So this is a Stirling engine power park. You can see large number of Stirling engine systems, and huge amounts of energy can be extracted. So these are the references. Please go through them and get better insights. With that, thank you very much. This is Dr. Unnikrishnan PC signing off.